Top 30 blockchain developer interview questions and answers. Preparing for a blockchain developer interview requires strong technical knowledge, problem-solving skills, and a solid understanding of decentralized technologies. This guide presents the top 30 blockchain developer interview questions, along with clear and concise 70-word answers. These questions focus on blockchain fundamentals, smart contracts, cryptography, decentralized applications, consensus mechanisms, and real-world implementation challenges. Use this comprehensive resource to boost your confidence, refine your expertise, and demonstrate your readiness for blockchain development roles. 1. What is blockchain technology? Blockchain technology is a decentralized and distributed digital ledger that records transactions across multiple nodes securely. It ensures transparency, immutability, and tamper-proof data storage using cryptographic hashing. Each block contains transaction data, a timestamp, and a hash linking it to the previous block, forming a secure chain. Its consensus mechanisms ensure trust without essential authority, making blockchain ideal for finance, supply chain, identity management, healthcare, and decentralized applications across industries. 2. How does a blockchain work? Blockchain works by storing data in blocks linked sequentially through cryptographic hashes. Each block contains validated transactions and references the previous block's hash, ensuring immutability. Nodes on the network validate new blocks using consensus mechanisms like proof of work or proof of stake. Once validated, blocks are added to the chain and shared across all nodes, creating a secure, decentralized, and transparent system where data cannot be altered without network consensus. 3. What is a smart contract? A smart contract is a self-executing program stored on a blockchain, designed to automatically enforce and execute terms when predefined conditions are met. It eliminates intermediaries, reduces delays, and enhances trust through transparency and automation. Smart contracts are commonly deployed on platforms like Ethereum using languages such as Solidity. They support decentralized applications by enabling functions like payments, asset transfers, agreements, and governance with reliability, security, and tamper-proof logic. 4. What is a decentralized application, DApp? A decentralized application, DApp, is software that runs on a blockchain or distributed ledger instead of a centralized server. It uses smart contracts to manage back-end logic and ensures transparency, security, and censorship resistance. dApps provide users with control over their data and operations, reducing reliance on intermediaries. Common examples include decentralized finance platforms, NFT marketplaces, gaming applications, and decentralized exchanges, offering trustless environments for secure peer-to-peer interactions. 5. What is a blockchain node? A blockchain node is a network participant that stores, validates, and shares blockchain data. Nodes maintain a copy of the ledger and support the network's decentralized structure. Full nodes store the entire blockchain, while light nodes store partial data. Nodes verify transactions, enforce protocol rules, and propagate blocks across the network. They play an essential role in ensuring blockchain security, consensus integrity, decentralization, and seamless peer-to-peer communication within the system. 6. What is a consensus mechanism? A consensus mechanism is a protocol used by blockchain networks to validate transactions and agree on the state of the ledger without a central authority. It ensures trust, prevents double spending, and maintains network integrity. Popular mechanisms include proof of work, proof of stake, delegated proof of stake, and practical Byzantine fault tolerance. Each mechanism has its strengths in scalability, security, energy efficiency, and decentralization, helping blockchains operate reliably under distributed conditions. 7. What is proof of work, POW? Proof of work is a consensus mechanism where miners solve complex cryptographic puzzles to validate transactions and create new blocks. The first miner to solve the puzzle earns a right to add the block and receive rewards. POW ensures strong security and resistance to attacks, but consumes significant computational power and energy. Bitcoin famously uses POW, making it secure, decentralized, and resistant to tampering through its robust mining network. 8. What is proof of stake, POS? Proof of stake is a consensus mechanism where validators are chosen to create blocks based on the amount of cryptocurrency they stake as collateral. It eliminates energy-intensive mining by selecting validators proportionally to their stake and reputation. POS enhances scalability, efficiency, and environmental sustainability while maintaining network security. It reduces hardware requirements and enables features like slashing to discourage malicious behavior. Ethereum transitioned from POW to POS with the merge. 9. What is a blockchain fork? A blockchain fork occurs when a network splits into two separate chains due to protocol changes or disagreements among participants. Forks can be soft, backward compatible, or hard, non-compatible. Soft forks require only majority upgrade, while hard forks create new chains if consensus fails. Forks occur for feature upgrades, bug fixes, and governance issues. Famous examples include Bitcoin Cash from Bitcoin and Ethereum Classic from Ethereum after the DAO incident. 10. What is cryptographic hashing? Cryptographic hashing transforms input data into a fixed-length alphanumeric hash using algorithms like SHA-256 or KEKAK-256. Hashes are deterministic, irreversible, and highly sensitive to input changes, ensuring data integrity. In blockchain, hashing secures block links, validates transactions, and ensures tamper-proof structures. Hashes also enable digital signatures, mining processes, and Merkle tree structures. Their strong collision resistance makes hashing essential for blockchain security, trust, and decentralized verification. 11. What is a Merkle tree? A Merkle tree is a binary data structure used in blockchains to efficiently verify large sets of transactions. Each leaf node represents a hash transaction, and parent nodes store combined hashes of their children. The root hash summarizes all transactions in a block, enabling quick verification without downloading entire data. Merkle trees improve scalability, reduce storage requirements, and ensure tamper detection, playing a crucial role in blockchain validation, like clients and distributed systems. 12. What is a private blockchain? A private blockchain is a permissioned network where access is restricted to specific participants. Unlike public blockchains, it offers controlled governance, faster transaction processing, and enhanced privacy. Organizations use private blockchains for supply chain management, banking, enterprise data sharing, and compliance-sensitive operations. Nodes are pre-selected, and consensus mechanisms are lightweight. While private blockchains lack full decentralization, they provide efficiency, confidentiality, and tailored controls suitable for business and institutional applications. 13. What is a public blockchain? A public blockchain is an open, permissionless network where anyone can join, validate transactions, and access data. It offers full decentralization, transparency, and censorship resistance. Popular examples include Bitcoin, Ethereum, and Solana. Public blockchains use consensus mechanisms like POW or POS to secure the network. They support decentralized applications, financial services, and immutable records. Although sometimes slower, they provide maximum trust, global accessibility, and robust security without centralized control. 14. What is a blockchain wallet? A blockchain wallet is a digital tool that stores private and public keys, enabling users to send, receive, and manage cryptocurrency securely. Wallets can be hardware, software, mobile, or web-based. They do not store actual coins, but provide access to blockchain-stored balances using cryptographic keys. Wallets offer features like seed phrases, QR codes, and multi-signature support. Security depends on safeguarding private keys, which act as proof of ownership and authorization. 15. What is gas in Ethereum? Gas in Ethereum represents the computational cost required to execute operations on the network, including transactions and smart contracts. Users pay gas fees in Ether, determined by gas units consumed and gas price set by market demand. Gas prevents network abuse by assigning costs to processing tasks. Higher gas fees speed execution, while congestion increases prices. Gas ensures resource allocation, network stability, and fair processing of decentralized applications and transactions. 16. What is Solidity? Solidity is a high-level, object-oriented programming language used to write smart contracts on the Ethereum virtual machine. It features syntax similar to JavaScript, supports inheritance, libraries, and modular programming. Developers use Solidity to build decentralized applications, manage digital assets, handle logic, and implement automated agreements. Its compiled bytecode runs on the EVM. Solidity continues evolving with improved security features, error handling, and development standards to support scalable, secure blockchain solutions. 17. What is the Ethereum Virtual Machine EVM? The Ethereum Virtual Machine EVM is a decentralized runtime environment that executes smart contract bytecode on Ethereum. It ensures consistent behavior across all nodes, making applications deterministic and tamper-proof. The EVM uses gas-to-meter computation, preventing abuse. It supports multiple programming languages like Solidity and Viper. By abstracting hardware differences, the EVM enables powerful decentralized applications, token standards, and complex financial systems on a global, trustless network. 18. What is a token standard? Token standards define rules for creating and managing blockchain-based tokens, ensuring compatibility across the ecosystem. Common Ethereum standards include ERC 20 for fungible tokens, ERC 721 for NFTs, and ERC 1155 for multi-token use cases. Standards specify functions like transferring tokens, checking balances, and approval mechanisms. They enable interoperability among wallets, exchanges, and dApps. Token standards simplify development, streamline integration, and ensure reliable performance for digital assets and decentralized platforms. 19. What is the difference between a coin and a token? A coin is a native cryptocurrency of a blockchain, used for network transactions, security, and governance, for example, Bitcoin or Ether. A token is created on an existing blockchain using standards like ERC 20, serving purposes such as utility, security, or assets. Coins maintain blockchain operations, while tokens represent functions or rights within applications. Tokens depend on underlying networks, offering flexibility for dApps, decentralized finance, and various blockchain-based ecosystems. 20. What is blockchain interoperability? Blockchain interoperability refers to the ability of different blockchain networks to communicate, share data, and transfer digital assets seamlessly. It solves fragmentation by enabling cross-chain functionality. Technologies like bridges, sidechains, atomic swaps, and interoperability protocols, such as Polkit Cosmos, and Chainlink facilitate these interactions. Interoperability enhances scalability, adoption, and user experience by allowing combined features, reduced silos, and integrated decentralized ecosystems across multiple blockchains, applications, and industries. 21. What is a blockchain oracle? A blockchain oracle is a service that connects blockchains with external data sources, enabling smart contracts to access real-world information. Since blockchains cannot fetch outside data themselves, oracles provide feeds like price data, weather identity, or supply chain updates. Oracle systems can be centralized or decentralized. Chainlink is a leading decentralized oracle network. Oracles enhance smart contract functionality by bridging on-chain logic with off-chain events for automated, data-driven execution. 22. What are blockchain layers? Blockchain layers categorize the architecture into multiple components for scalability and efficiency. Layer 1 refers to the base blockchain, such as Ethereum or Bitcoin, handling consensus and security. Layer 2 solutions like Polygon, Lightning Network, and optimistic rollups process transactions off-chain to reduce congestion and improve speed. Layer 0 includes networks like Polkit providing interoperability. These layers work together to enhance performance, decentralization, and scalability across blockchain ecosystems. 23. What is sharding in blockchain? Sharding is a scalability technique that divides a blockchain's data into smaller, manageable partitions called shards. Each shard processes its own transactions and smart contracts, enabling parallel execution that increases throughput. Instead of every node validating all data, nodes handle specific shards, reducing computational load. Sharding helps blockchain scale for high-volume applications while preserving decentralization. Ethereum aims to implement sharding for improved performance in future network upgrades. 24. What is blockchain trilemma? The blockchain trilemma describes the challenge of achieving decentralization, security, and scalability simultaneously. Most blockchains optimize two aspects while compromising the third. For example, highly decentralized and secure networks like Bitcoin may struggle with scalability. Layer 2 solutions, sharding, and alternative consensus mechanisms aim to resolve this trilemma. Developers design architecture carefully to balance these competing priorities, enabling faster, more secure, and decentralized blockchain networks for broader global adoption. 25. What is a 51% attack? A 51% attack occurs when a malicious entity gains majority control of a blockchain's mining or staking power. This allows them to manipulate the network by reversing transactions, halting confirmations, or enabling double spending. Proof-of-work blockchains are more susceptible, while proof-of-stake networks use slashing to prevent such attacks. Strong decentralization, distributed validators, and robust consensus mechanisms help blockchains defend against these security threats effectively. 26. What is a multi-signature wallet? A multi-signature wallet requires multiple private keys to authorize a transaction, increasing security and reducing risk of unauthorized access. It distributes signing authority among several parties or devices. Multi-sig wallets are used in exchanges, businesses, and decentralized governance models to prevent single-point failure. They support advanced features like threshold signatures and joint account management. This added layer of protection enhances trust and accountability in cryptocurrency storage and transfers. 27. What is a DAO? A DAO, Decentralized Autonomous Organization, is a community-governed entity powered by smart contracts. It operates without centralized leadership, using decentralized voting mechanisms where token holders propose and vote on decisions. DAOs manage funds, execute actions automatically, and ensure transparency through blockchain records. They are widely used for investment groups, protocol governance, and decentralized project management. DAOs promote trustless collaboration, democratic participation, and sustainable decentralized ecosystems across blockchain communities. 28. What programming languages are used in blockchain development? Blockchain development involves multiple programming languages depending on use cases. Solidity and Viper are used for Ethereum smart contracts. Rust is popular for Solana, Polkad, and Near. Go powers Hyperledger and Cosmos SDK. Python and JavaScript support tools, scripting, and dApp development. C++ is foundational for Bitcoin. Developers choose languages based on performance, security, ecosystem support, and platform requirements, enabling robust blockchain applications and smart contract functionality. 29. What is a blockchain explorer? A blockchain explorer is a web tool that allows users to view real-time blockchain data, including transactions, block details, wallet addresses, and smart contract interactions. It provides transparency by allowing anyone to track the movement of assets and verify network activity. Explorers also display gas fees, token transfers, and block confirmations. Examples include Etherscan, Blockchain.com, and Solscan. These tools are essential for developers, users, auditors, and researchers analyzing blockchain networks effectively. 30. What are the real-world applications of blockchain? Blockchain has diverse real-world applications, including cryptocurrency, decentralized finance, digital identity, supply chain transparency, healthcare records, cross-border payments, voting systems, property management, and energy trading. It enhances security, transparency, and efficiency across industries. Businesses use blockchain for asset tracking, fraud prevention, and automation through smart contracts. Governments use it for public records and compliance. Its decentralized nature enables trustless operations, reducing intermediaries and improving reliability globally. Blockchain development offers a rapidly expanding career path filled with innovation, problem-solving, and opportunities to build transformative technologies. By mastering these top 30 interview questions and answers, you strengthen your technical foundation and prepare confidently for employer assessments. Continue practicing hands-on coding, exploring new blockchain frameworks, and staying updated on emerging trends. With persistence and skill development, you can excel in blockchain roles and contribute meaningfully to decentralized digital ecosystems.